we're going to go ahead and do example 2 using a second derivative of a parametric function, but we're going to combine that with another skill set that we learned. So I give you that x of t equals e to the t and y of t equals cosine t. So I'm going to ask you to do 3 things, but on a real AP, they probably won't ask you to do all 3. They'll probably ask you to do B and C, with A being an implied step that you need to do in order to find B. So part A, find dy dx. Part B, find d squared y dx squared. And part C, use A and B to determine if the curve has a max, min, or neither at t equals 0. So we've seen this question in some of the AP review questions that we've done. When this question is posed, especially when this question is posed after being asked for a second derivative, this is asking you to do the second derivative test. So we're going to walk through that right now, but essentially what the second derivative test says is that if you are level, meaning this first answer is 0 at 0, and concave up, right, so level and concave up would look like this, then you're a min. If you're level and concave down, meaning this is 0 but this is negative, then you're a max. And if both of them are 0, then the test is inconclusive. Generally, they don't push you into this particular problem if it's going to be inconclusive. So it will probably be one of those 2 scenarios that I just drew. So let's go ahead and do it. So for part A, my dy dx is just y prime of t on top of x prime of t. So my dy dx is going to be y prime of t, which is the derivative of cosine of t, so negative sine of t, on top of x prime of t, which is everybody's favorite derivative. Derivative of e to the t is just e to the t. So that's my part A, easy peasy, totally friendly. Now my part B is the thing we went over in example 1 before this, and also one more time before that. We have to derive, with respect to time, my dy dx that I just found in part A, and then underneath that I have to put my x prime of t, which we just found as well. So I'm going to derive this guy, which is a quotient rule now, right? So I'm going to derive this guy with respect to t. So my second derivative, d squared y dx squared, is going to be the derivative of this guy, right, which is a quotient rule. So when I derive this guy on the top, it's going to be low, right? D high is going to be a negative cosine of t, rather, right? So low d high minus high, which is a negative sine of t, d low, which is that e to the t, draw the line, square the low, which would be an e to the 2t, because it's an e to the t quantity squared. So that's this derivative all over. I still have to divide it by x prime of t, which is still an e to the t. So I'm pretty sure what happens if I clean this up a little bit, and I get that it's kind of messy looking. I'm going to factor out an e to the t on the top and get essentially a negative cosine of t plus a sine of t, right? And then on the bottom I have an e to the 3t, because this guy ends up on the bottom, meaning I can cancel this e to the t with one of these guys and make it an e to the 2t. So my d squared y dx squared in its nicest, happiest form is a negative cosine of t plus a sine of t all over an e to the 2t. Great, there's my part B. So now what part C is asking me for, as we discussed, is it's leading you into that second derivative test. So essentially, I want to plug in t as 0 to both of these and see what I get. So if when I plug in 0 to my answer to A, I don't get a 0 out, then the second derivative test is dead in the water and I have to try something else. More specifically, I don't really have to try something else. It's just neither. It's not a max or a min. If when I plug in my 0 to the second derivative, if I get 0 out, if they're both 0, then it's going to be a situation where I need another test. I actually can't answer max, min, or neither. So generally when you do this, you should get 0 in your first derivative. If you don't, you should double check that it's not you, that you didn't just add wrong or something. So my dy dx, evaluated at t is 0, is going to be a 0 on top of an e to the 0, which is definitely a 0 over 1, so that's 0. So far I know that whatever function I have, it's level at 0, right? So it's level, it's got a horizontal tangent line. The second question is, what is d squared y dx squared evaluated when t is 0? When I plug that in, I get a negative 1 plus a 0 on top of an e squared. Well, that's a negative 1 over e squared. Now, I always tell my students you can't actually think of e as 3 because that's wrong. It's not a good approximation if you were actually trying to find a value for e, but if in your brain you're trying to think about what this number might look like, it's approximately a 1/9, negative 1/9 rather. So since this is less than 0, right, I now know that what's happening if I draw my picture, sorry, I boxed myself into having no room. So what is now happening here is that my answer to C is that my curve is flat and concave down, which means that this thing is a max. So My answer is that it's a max. Again, it's nice if you can spot that you're coming into a second derivative test. It makes your life a lot easier if you can see ahead of time that this is the thing they're asking for.